Hello, thanks for stopping by. After I did my last video on the Zener diode tester, I got a request from Bill, old 64 Goat. He wanted to know how you'd take and test them just using a power supply. In case you didn't want to build the tester, or in case you're testing diodes that are out of its voltage range, since it only goes to 30 volts. Uh, Bill plays around with tube equipment. He has some Zener diodes that are in 150 to 200 volt range. So the first thing you have to do with any of them is you have to get the data sheet for that particular zener. This data sheet here is for the half watt ones that we've been playing with. And you can see that down to 12 volts, they were all designed to take and draw 20 milliamps of current. So that, to get an accurate reading, that's what you have to take and have going through the zener. When you get down to our 24 volt one though, it's down to 5.2 milliamps. So when we get to that one, we're going to have to take and cut it down. And the amount of current changes with the wattage of the zener. If you look at the 1 watt data sheet here, they're drawing like 75 milliamps, 40 some milliamps. So you have to take and get the sheet that goes with it. You get up to the ones that Bill was really questioning about, the 150 volt and the 200 volt. They're 5 watt zener diodes, and the 150 volt, you're talking like 8 milliamps, and you're down to 2 milliamps for the 200 volt. If you take and try to draw, too much current through it, you're just going to take and burn it up. Now, there's two ways really of testing it. You can take and set up a circuit like this. The 100 watt resistor there is just as a protection to keep it from drawing too much current. Put an ammeter in the circuit, your voltmeter of course across the zener to take and measure the voltage. And then using a constant current power supply, taking and putting the required number of milliamps through. And after it stabilizes, taking and reading your voltage. Let's go to the bench, use this method, and see how they come out. Okay, here's our first setup. I have the power supply set at 28 volts, but I have it current limited at 20 milliamps for the first two tests, for the 5.1 volt and for the 10 volt. Turn it on. Limited to 20 milliamps. 5.07 volts. Take that one out. Put the 10 volt one in. Apply power. About 10.75. Now our 24 volt, I have to turn the current down to 5 milliamps per the data sheet. Apply power. .6, 24.7. Seems to stabilize there at 24.8. One thing to remember with the Zener diodes is that they are very temperature dependent. In fact, if I take and turn that back on again, just grabbing it with my fingers takes and changes the voltage because I changed the temperature of it. So you have to let them stabilize. Now another way you can take and do it if you don't have a constant current source is to take and use a circuit like this. You'd put a resistor in series with the Zener that takes and limits the current to what the Zener diode is expecting. And figure out what the resistor is. You take your voltage power supply, which of course has to be higher than the Zener, subtract the Zener voltage, and then divide it by the current that you're looking for. Now for the 3 diodes that we've been testing or whatever, if you remember, the 5.1 volt and the 10 volt want 20 milliamps, the 24 volt wants 5 milliamps. And for this test, I'm going to use a 28 volt power supply, that's unlimited. There's no current limiting on it. So to limit it, the 5.1 to 20 milliamps, you'd use the 1K2 resistor. 10 volt, you'd use the 910, and for 5 milliamps through the 24 volt, you'd use the 820. Now let's go out to the bench and see how things turn out using this method. Okay, now here's our second setup. I have the Zener diode with calculated resistors. For the 5 volt, it's a 1K2 resistor to limit it to 20 milliamps. For the 10 volt, it's a 910 ohm resistor to limit it to 20 milliamps. For the 24 volt, it's an 820 ohm resistor to limit it to 5 milliamps. Now we'll put 28 volts across the whole circuit. Our 5 volt is reading 5.04 volts. Our 10 volt around 10.66, 10.67. And our 24 volt, 24.7. So you can see it's really simple. You just have to take, like I said, starting with your data sheet, figure out what current you need, and then figure out which method you want to take and use, whether you want to take and use a constant current source to take and limit the current, or use the resistors to take and limit the current. And of course, remembering to take and, give it 30 seconds or so, I'd say, to take and warm up to its operating temperature with that current going through it to get what your final reading is going to be. Hope this answers your question, Bill. Hope it helps other people too. Thanks for stopping by. Have a good day.